Alright, so welcome to today's learning again. Today we are going to focus on Scrum as in that of Scrum basis. So we will cover Scrum as it, how are they being formed, how software as it is being formed, how hydraulic as it is being formed, how chloric acid, perchloric acid, hydrobromic, and this and that of nitric acid as a whole. So we have 7 Scrum acid mostly and that of 8 Scrum bases, right? So these are the Scrum acids and these are the Scrum bases. So right now we say Scrum acid. What is a Scrum acid? In short, we can say that a Scrum acid is an acid or an acids that dissociate or decompose in water or ionize completely in water. What does that mean for something to ionize in water completely? Let's say for instance you have a classroom as a student, as a teacher, and you have 10 students. So those students came into the class and all of them sat within a chair. They were in rush to sit in a chair, right? So in that capacity or in that scenario, they are all excited to be seated in their chairs. Unlike maybe the next day, those 10 students came, they wasn't happy. And chairs were all in the classroom, but only 7 were able to sit in the class and remaining 3 never sat. So in that scenario or that capacity, we can refer to those 3 that never sat as weak acid because they do not ionize in water completely. Likewise, you can also relate that to strong base and that of weak base. Alright, so let's get this clear. We say strong acid are acids that dissociate or ionize or decompose in water completely. What does that mean right here? If we have sulfuric acid to be one of the strongest acids that we all know of, so how are these compounds formed? So in this video we are going to give you a look on how those compounds were being formed, right? So the first one is sulfuric acid. Sulfuric acid is said to be H2SO4. So we said sulfuric acid is a strong acid because it dissociates in water completely. Alright, so if you are to break this compound apart, this is a compound that comprises of hydrogen, that is 2 of them, sulfur, and 4 oxygen. If you are to dissociate this compound, when we say dissociate means to break apart, to ionize, to separate. So if you are to separate this compound or to dissociate them, it tells that you will have H plus SO4 2 minus. Do you know what this is about? It tells that this particular element is hydrogen ion because of this charge, and we have sulfate ion because of the charge here. So this is a compound, an ionic compound, and this is an ionic element, right? So in this scenario, if you are to make this to be the reverse reaction, that is an aerosol and an aerosol, reversible. Or let's bring this to this side, making it as the reactants. So right now it looks like a product right here. If you do this, get a product. So we can bring the product aside to make them as the reactants. That is, we say H plus SO4 2 minus. So right here, if you bond hydrogen ion to that of sulfate ion, you produce sulfuric acid. How? This two you are seeing right here, this two you are seeing right here, it literally belongs to sulfate ion. So it tells that this particular compound right here, it can still accept two more electrons, because chemistry says that if you have a negative charge, that tells that you can still accept electrons to obey or to satisfy your duplex or your octet rules, mostly the octet rules, right? So this two you see right here, it has to give it to hydrogen, then it accept. Once it accept, they become a subscript. In other words, it comes this way, you will have H. This two you see here, it get it to H. See, because the subscript, it becomes 2 right here. Here is 1. So this particular one, it gets to this particular compound, except it just becomes SO4, because you won't put any charge here again. So it becomes SO4. So it was how this compound was being formed. In other words, you can draw the structure of it in the Lewis form to tell you that this particular compound will still accept 2 more electrons. How? If you make this as a central atom, an element within the center, so we have S right here. We have S. S is in group what? It's in group 6, which is sulfur. Or it's in group what? It's in group 4, which is oxygen. So right here now, you have this compound, this element rather. 1, 2, 3, 4. It has 6 electrons in its outer shell. 4. You can double that by saying 5, 6. So it becomes completed. We have 4 O connected to that. So you could write O right here. 1, 2, 3, 4. O and S, they are in the same group. So they have the same valence electron in the outer shell, right? So we have 1, 2, 3, 4. We say 5, we say 6. We say 1, 2, 3, 4, 5, 6. 1, 2, excuse me. 1, 2, 3, 4, 5, 6. So how many lone pairs does O have? O have 2 lone pairs. Oxygen have 2 lone pairs. You have 1 up here. It's a pair. 1 here is 2. So each of them has 2 lone pairs. Likewise, sulfur has 2 lone pairs. 1, 2. Because they are in the same group. So right here, if you have to bond them, this O you see here, this one you see right here, it bond to this, and this 2 you see it has 2 right here, right? So this can bond to this. Don't put this last one that we forgot, or this last one. 1, 2, 3, 4, 5, 6. So right here, this can bond to this bond right here. It get bonded, and this 2 can bond right here. Also, it's right here and here. So this 2 can bond to this one. Then this can bond to this. So you check that. If you try to check that right now, you have 1 bond, 2, 3, 4. So this you have triple bond twice. Excuse me, you have double bond twice. So we can do this like this. We can like take this from let's say we take this, it's still vacant, we can put it right here. We put this right here. Then we take this one, then it's still vacant. The one is still vacant, we can place it right here. Okay, so if you look here now, you have this. There is a pair right here. Let us bring this together so you can know that this is a pair. This is a pair. So this just still contain lone pair right here, or lone pair is being here also. So alright, so I hope you understand that. We can just erase that for clarity. So you have a pair here. There is a pair, 1, 2. There is a pair right here. This one you see here, it can still accept 1 more electron. As you see right here, you can see accept. So this tells that they can accept one more electrons, and also this can accept one more. So we have one to be accepted here and one here. So 1 plus 1, it gives you 2. It will have this -2 kin about, meaning what, it can still accept 2 more electrons. So since you have bonded H to O now, it tells that you have to put one H right here and one H right here in order to satisfy the octet rule. So if you check this now, each of them will satisfy the octet rule or the duplex rule. Octet means 8. So this becomes 2, 4, 6, 7, 8. Because it's share, so it becomes 8. The S becomes 1, 2, 3, 4, 5, 6. The share 7, 8. It's satisfied. Then it's satisfied. This becomes 1, 2. It obeys the duplex rule. So S obey the octet, O obey the octet, and H obey the duplex rule. So they become a covalent compound right here because they share electrons. In this case, you saw doing arrow like this, they never transfer. The reason is very simple because you have positive charge and negative charge, they attract. It was how we did it in a short form, but they never transfer the charges logically. But because of the positive sign and negative sign, we just swap them. Hope you understand that. Alright, so I'm done with that. So the next thing is to see how this particular compound was being formed. That is hydrochloric acid. How was it formed? Well, for that, you have HCl. So you have HCl. If you decompose this, into separate, or if you analyze this, when they say, oh, you analyze this compound, meaning that it should contain charge if you do everything. So here it tells that H was bonded to chlorine and H is in group 1, so it has positive charge. It's very simple. It's 0 plus. Which group is chlorine in? It's in group 7 or group 17. It has negative charge. You can say accept one more. So it becomes Cl minus. Right? So positive and negative, they come together. Here is positive, here is negative. There is non-metal, there is non-metal. So they will share an electron. So you see positive and negative sign here. So this becomes a covalent compound because they share electrons or charges. Alright. So when you look here now, the next one is this. How this skin about? You have hydrogen, you have chlorine bonded to what? To O, to O3. You know this will be what? What would this be? It's H plus. Then ClO3 will be which are your compound? Well, this contain when you say H, ClO3. If you break it apart, when you get H plus, because here you are seeing one here, but it's invisible. You're not still R, but invisible right here. There's invisible one right here. So when you say Cl plus, ClO3, you put minus here. When you say that, check it out. If this is correct or not. This is your assignment. Check this out if it is correct as this or not. Let me know. So the next one is hydrobromic acid. So this is in group 1. Why is this below? It's in group 7 of 17. So it just 1 to 1. So just become it was H plus B arrow minus in case of H B arrow. How this was formed. You see what this one here too? It was H plus R. And R is in group 7 or group 17 is negative. So it becomes H this. What about this? It was H plus. This was a ionic compound to be NO3 minus. There was negative charge right here. So it was NO3 minus. So they found this to be, well, they can still accept one more electron. They will have a bond to the H here. It just becomes HNO3. So what you notice here is that all acids contain hydrogen. Why? Because they want to lose this hydrogen as time goes on. They want to donate it. So it should contain H. All better contain OH minus, as you can see right here. Alright, so that is it. We can move to strong bases. It's very easy. It's easy. Yep. Do you know how this compound was being formed? Lithium hydroxide. Initially, it was Lr plus OH minus. Why? Because this guy is in group 1, so it has positive charge. Hydroxide, it contains negative charge because H will be H2O. Say it lost one of H, it lost one H. So it become OH minus, meaning what? It can still accept one more to obey or to certify octet rule or a duplex rule. So it this OH minus, it can still accept one more. So in the case now, if you link this to this, it becomes certified. But let me want to lose one electron. Let me want to accept. Let me lose it, can we accept it? So we have to produce lithium hydroxide OH minus. What about this potassium? It's in group 1. You want to lose one electron, so it was plus. OH was what? OH minus. So they form potassium hydroxide. What about sodium hydroxide? Sodium is in group 1. It's Na. It has positive because it's in group 1. You want to lose plus OH minus. So they form NaOH. Is that simple? So what about this guy right here? Cesium hydroxide. That is in group 1. You want to lose 2. So it was CS plus OH minus. So they want to lose 1. They don't want to accept 1. So it's certified right there. So it becomes CS OH. What about this guy here? Calcium hydroxide. What the two stand for right there? This two here initially belongs to what? Calcium. Why? Because calcium is in group 2. It wants to lose 2 electrons. Right? So it was written as just initially as Ca 2 plus OH minus. Remember, this is an ionic compound right here. So this charge here belongs to both O and H. It's not only for H. This belongs to both O and H. So if you bond calcium ion to hydroxide anion, this two you see here is like, this is a metal. It wants to lose 2 electrons. And this is a non-metal, and this is a non-metal. So it tells that this guy wants to do what? To give 1 electron. All of them. This minus 1 mean what? Both O and H want to give 1 to certify like octet or a duplex rule. They got to give it with 2. So they will transfer the electron right there because this is metal. This is what? Non-metal. Because what? Ionic bonding. It is the transfer of electron between metal element and what? Non-metal element. So right here, this guy gives the 2 to this particular compound right here. Both O and H, they will accept it. So right now they become calcium. Then this molecule right here, it gives it to calcium. They change the charges right there, right? So it becomes calcium now will have only 1. So BCA. Then you must say parenthesis. Why? Because you do this, then you put both O and H inside A. You say O, H, then you close it. Then 2 here, you see here, all I give it to the guy here. It belongs to both calcium and it belongs to both O and Y, H. In other words, you can expand this compound. If you do this now, if you do this 2 it means for both this and this. It's not for this guy outside. No. It's for both this and this. So if you say 2 times O, it will be O2. 2 times H, it will be H2. Right? Then you have to see it right there. So let's see if this correct to this by calculating for the molecular weight of this compound. Right? Or let's say the oxidation number of this particular compound here. What is calcium? Oxidation number for calcium is what? It's 2 plus. It's equal to 2. So it's 2 plus. Calcium is 2 plus. It's 2. Okay, say 2. Let's say we know O. What is H value? It's plus. How many H here is 2? 1 times 2. So it becomes 2 right there. We assume we know O. 1 find O. And we say that here there's no charge here. So it's 0 in total. So it should be equal to 0. The total charge is equal to 0. So we have 2 and 2 here. So which number if you add 2 and 2 on it, it will give you 0. Which number? You say 2 plus 2 will give you 4. So total is 4. Alright, so which number if you add, let's say if you add to 4, which this number, if you add to 4, will give you 0. It will be what? It will be minus 4. Right? It is true. When you say 4, you minus 4, it will give you what? 0. It tells that the O charge of O should be what? Minus 4. What is the charge for O, for oxygen? We say we don't know, but we won't find it. So we say that minus 4 now, minus 4 will be for O. O is what? Is minus 2. For the charge of O is minus 2. You say minus 2 times how many O here? Is 2. Minus 2 times 2, it give you what? 4 right there, negative 4, right? So we say 2 plus 2 give you 4. 4 minus the negative 4 and give you what? 0. So the charge for O here is what? Is negative 4 in total. Let's see the correct here. Question is 2 plus is 2. Then we say here now, what is O value here? Here is 1 here. 2 times 1 is 2. What is 1 there? 2 times 1 is 2. So we'll give you this particular compound written like this. So you can either say CaCOPOH equals to all like this. All like this. And the same thing right here. It's the same thing. Here we have expand it. Here we get contains A. It's the same thing right there. So why? Because of where I was. Okay. So why? Because of, let's say you have rubidium hydroxide. Here is in group 1. So it's arrow B. So it's arrow B is in group 1. We have positive charge plus hydroxide right here, OH. So what? OH minus. So that give you arrow B OH. Why? Because of barium hydroxide. You see 2 right here. The 2 tells you that it belongs to the guy initially. So it's in group 2. So it was Pa 2 plus OH minus, I give you this particular as Ba OH equals it in 2 here, because this into this and then 1 into this here. They change right there. How about cesium hydroxide? It's the same thing, right? So this 2 for this guy here, it was S arrow 2 plus equal 2 plus OH minus. So it gives us S arrow minus OH equals to 2. That's the stuff right there, man. So this is how we learn about strong acid and strong base. This is how they were being decomposed. So the next thing is to learn about hydrous acid and that of hydrous base. So we can just do that for short. So what is hydrous acid? Hydrous acid are acid that increases the concentration of hydroxide of hydrogen ion in water molecule. How about hydrous base? Hydrous base is a base that increases the concentration of hydroxide ion in a water molecule. So for hydrous acid, let's say for example we have H2. We have H2. We say H2SO4. So we'll break this guy apart, or we'll decompose it, or we'll analyze it. We'll get H plus SO4 2 minus. So they say identify the hydrous base. Identify the hydrous acid in the equation. So this will be hydrous acid because it says that it is an acid that increases the concentration of H plus in a water molecule. So just because the hydrous acid right here. So you say this is hydrous acid, right? So these two, if you have HCl, you decompose it, you have H plus Cl. So in short, whenever you break down a compound and you form H plus, that H plus becomes an hydrous acid. So what about hydrous base? When you break down a compound and you form OH minus separate, that becomes hydrous base. Example, lithium hydroxide. We have LR OH. When we break it apart, we have LR plus OH minus. So this becomes the hydrous base because we say that hydrous base is a base that increases the concentration of hydroxide ion in water molecule. So this become the amino acid right here and amino base right here. So what become the next one again? We say potassium hydroxide. We have KOH. When we break it apart, we have plus OH minus. So this become the amino base. So you can go there by doing this. Always start the OH minus become what? The amino base. Hope you understand that clearly. It's very easy to understand. And you can do this. You do this. So always not OH minus become amino base. H plus become amino acid. It's very simple. Right? So we did conjugate acid and conjugate base, everything. Right? So we did that in our other video, I think yesterday. Okay, here's a hint giving you. You have to know those strong acid and strong bases. Yeah. So the next video I'm going to produce about, I would say, calculating pH scale, everything. We do that, then we'll move to redox reaction. From there, solubility, quantum mechanism. We have other ones. Thank you, and please don't forget to watch and share. Have a blessed day.